Hello everyone, Siddharth this side, and in this video we will be solving another question on Geek for Geeks, which is left B of a binary tree. So in this problem we have given a node root, and what we have to do if we will stand on the left side of the tree, and the view that we will get for this given tree, we have to store those numbers into an array list, and we have to return that. So how we can solve this problem, let's see. So suppose this is a tree: 1 2 3 4 5 6 7 and 8. So what we have to do, we have to store 1 2 3 6 and 8 into an array list, and we have to return that. So what we can do, from this only we will be getting clear idea. Either we can use level order traversal, because as we have to print only the first node, so in the recursion we can call the left, first we can call the left childs, then we will call the right childs. So this is one approach, and the second approach that we can use is level order traversal, where we will traverse to the each nodes, and we will add uh, the childrens of that given node. And for adding the first node only, we can apply some condition. If you will try to think that we can add a for loop and initialize and count variable, and we will initialize it to 0, and uh, again and again we will check if this count is 0, or we can initialize it to 1. So if it is 1, then only we will be adding the node. So this will add only the first node in the level order traversal. So this is the first one approach, and the next approach is in the recursion. What we can additionally pass into the calls is the depth. So here we will pass depth as 0, and also we can pass our array list. Now array list size is 0 and depth is 0. Now this we can use this concept as both of the size and 0, both of the size of the array list and the depth, it will always be equal for the first node. You can observe that if we will increase the depth by 1, so depth by is equals to 1, and we will be adding this node to array list. So here al dot size will become 1 also. So we will add this 2 as well. Same for this. These two variable will be same here, and for here it is 3 and it is 4. Now if you will try to think for this, like if it will return from here, it will return from here, it will return from here, and it will go for to the right child, but here the al size will get bigger, because 1 2 3 4 5 we already uh, will have added 5 elements here, and our al size at this level will become 5. Al size will become 5 here, and if we will try to check, here the depth is 3, and for the next call here depth is 4. Now if we try to match these, they will not match. So that's why this will not be adding this node into an array list. So this is the approach. Now let's code out this approach. So first let's handle the edge case, where if root is equals to null, in that case we just have to return a new array list, which will going to be empty array list of. Okay, now after this, what we have to do, uh, let's define this method with left. We will be passing a root, and we will be passing a depth as 0, and we will be passing our array list as well. So let's make an array list as well. So array list integer is equals to al is equal to new, sorry, this should be new array list. Okay, so we will be passing this to as well, and in the end we will be returning this array list. Now let's write the function, this left function. So its return type will be void, as we will be updating array list only. So void left, and we will be receiving our node root, and after that we will be receiving depth, and after that we will be receiving an array list of integer. Let's named as a al, as same as we defined here. Now after this, let's handle the base case. If root is equals to null, we will be returning from there. Now another base case that I had told you is to check for the depth and al dot size. So if our depth is equals to al dot size, if this is the case, then we have to add that node into our array list. So al dot add the root dot data. Now after this, what we have to do, we just have to call for the left and right child. So left root dot left, and let's increase the depth as well for each recursive call. And after that we have to pass the same array list here. Now let's call this again for the right child as well, and let's increase the depth and array list. Now after this we just have to the function, this function is already got completed. Now let's try to run this code as well. Okay, so there should be semicolon here. Now let's try to submit this as well. So all the test cases have been processed. So thank you. See you in the next video. Bye.